Hello everyone. So in last video we are discussing about this problem. Okay, so that is molarity and molality. We calculated that one, but because of issue, that is mole fraction, we didn't find out. Okay, so here I solved it. Okay, this is a mole fraction. How can we find? See here. So here I got, this is a mole fraction of Ki. They are asking there. So mole fraction of Ki is equal to number of moles of Ki and the total number of moles of solution, that is Ki plus H2O. So when we substitute the values of that given data, so we will get 0.0263 is a mole fraction of Ki, and how to find out the mole fraction of H2O means, so 1 minus mole fraction of Ki if I do means then we will get mole fraction of water also. So like this way we can find out the mole fractions by given data. So now in this video we are going to talk about a new topic of solution, that is only called as a solubility. So very important. From here only the dilute solution topic will be going to start. So what is the solubility means? So we know that lot of examples are there, like when salt is adding to the water, then after some time it will be disappearing. Where that will go? It will dissolve in the water. So now we will define solubility. So what is solubility? We can say solubility means amount of, or how much amount of solute will going to dissolve in a given solvent. Means I am having, for example, I am having one beaker here. So in this one water is there. So now I am going to add some sugar. So after some time, so we are going to get one solution. So this is a sugar solution. So now what is solubility here? So this sugar I took now, added into water now. So here water is there. Water. So how much sugar is dissolved in this particular solvent, that is only called as solubility of this solid. So solubility will be different. Suppose if we take liquid also can soluble in one liquid, and solid also can be soluble in one liquid. So here, that's what I said in the starting of this solution. So in this solution topic, what we are going to talk about? In this solution topic, we are going to talk about liquid solution. Liquid solution means we are having three cases. First case is what? First case is, that is gas in liquid. Second, liquid in liquid. Third case is what? Solid in liquid. So these three cases we are going to deal in this synopsis, or in this chapter, that is solution chapter. See, gas in liquid. So here gas is solute, here gas is a solute, and liquid is a solvent. Both combined we can call it as a solution. Liquid is a solute, liquid is a solvent, solid is a solute, liquid is a solvent, like this. Okay, now so gas can also be dissolving in water or any liquid, or liquid also can be dissolved in water. Okay, and solid also can be dissolved in water. So now there are different factors which affect the solubility. Okay, those factors we are going to study in this class. Okay, so that's factors affecting solubility. So which are those factors which are affecting solubility? Is that first important factor is nature of solute or nature of solvent also. Both are same, both will come in same factor. So second one is important is that temperature factor, and third case is that pressure factor. So this pressure factor only gives us to one law, that is only called as Henry's law. So in this pressure factor we are going to deal one law, that is only called as Henry's law. Okay, so this is how these factors we are going to study in this video. Okay, first factor, let me take that, that is nature of solute or nature of solvent. See, we will take one example here. So let me take one example, that is, for example, I will take see this one, that is salt and sugar. This salt and sugar, if I am going to add into water, so what will form? So these will form, two solution will form, one is a salt solution and sugar solution will form. Sugar solution means salt and sugar are soluble in water, correct? Suppose I am taking this salt and sugar only, I will take, but now this time I will not take water as a solvent. Now I will take solvent is benzene. What will happen means, now no solution will going to form, no solution means these salt and sugar will not going to dissolve, no dissolution in benzene. Okay, so this is one thing. One more example I will take, for example this one, I have heard about naphthalene balls. Okay, naphthalene balls or naphthalene. So when I am adding this one to water, this will not dissolve, naphthalene will not dissolve, naphthalene will not dissolve in water. But in the same way, if naphthalene I am going to add in benzene, will get solution, that is naphthalene will dissolve in benzene. So this example, by this example we can easily say that, means some molecules are dissolving in some solvent, some molecules are not dissolving in some solvent. Yes, that is only now. So that is only called as nature of solvent. If solute is polar in nature, then those will dissolve in polar solvent. If solute is non-polar, those will dissolve in non-polar solvent. Okay, so this is a thing. So by this one only we can get one law, that is only called as like dissolves like, means polar will dissolve in polar solvent, non-polar solute will dissolve in non-polar solvent only, vice versa is not possible. Like dissolves like means what? Polar will dissolve in polar, non-polar will dissolve in non-polar. So this is a factor about it is nature of solute or nature of solvent. So here, so next we are going to take about one more second factor, that is temperature factor, very very important factor, temperature factor. See, temperature factor, when I am taking, see, dissolution means what? First, dissolution means if I am adding any salt or if I am adding any solid into water, it will dissolve, or dissolving of salt in water, salt or anything, any substance, we can't say salt only, any substance we can say. Substance in water is only called as dissolution. Okay, so this dissolution process will be two types, that is exothermic process also will be there, exothermic also and endothermic also. Means solute plus solvent always will be in equilibrium with solution, means solute will dissolve in solvent and form solution, and this solution again decomposes and forms solute. Okay, so this equilibrium always will be there. If any variation is done in this equilibrium process, then we will get either solute in more quantity or solution in more quantity, like that. Okay, so now let me come to the point again. So dissolution will be two types, one is exothermic type, one is endothermic type. Okay, it means what? For example, I am taking this one. If I am adding NaCl solute in water, sodium chloride I am taking in water, and it will give sodium chloride solution, it will give. So this is exothermic process. Exothermic process. If dissolution of salt is exothermic process, then in this case, if temperature increases, if temperature in sorry, no, this is not exothermic process, this is endothermic process. Sorry, this is endothermic process. Endothermic process means what? I have to give the energy to make it dissolve, then it will going to dissolve. Okay, some amount of energy is required to make them to dissolve. Okay, so that's why it is an endothermic process. Now, in case dissolution is endothermic process, if dissolution is endothermic process, then if temperature increases, then solubility also increases. Remember, if it is endothermic process, then if temperature is increasing, then solubility also increases. Next, suppose I am taking one more example, that is, for example, you take this one, that is calcium chloride. Calcium chloride, if I am adding into water, it is also going to form a solution, but this is a exothermic process. Exothermic process means it is only releasing energy. After dissolving, after forming solution, it is releasing energy, and now if exothermic process is there, if dissolution is exothermic, if dissolution is exothermic process, then if temperature increases in such condition, if temperature increases, then solubility going to decrease. Solubility is going to decrease. Remember, if dissolution is endothermic process, then if temperature increases, solubility increases. If dissolution is exothermic process, then solubility decreases on increasing the temperature. So these 2 points very important regarding solubility of salt or solubility of solid substances in water or in solvent. Understood, I hope. So this topic is understood for everyone. So next, coming to the, suppose I am having gas in liquid. In this case, what will happen? In this case, so always remember, if temperature increases, then solubility of gas decreases. If gas is present in liquid, then if temperature, I am going to increase the temperature, then solubility will, yes, of course it will going to decrease, because if I am giving energy, by taking that energy, gas will come out very easily. So that's why the solubility will be decreasing. So that's why, so one point have you remember, so you have to remember, so aquatic animals will be there, no? These aquatic animals, those are very comfort in cold water than hot water. Why? Because what is the statement? See, aquatic animals, those are very comfort in living in cold water rather than hot water. Why? Because if I am increasing temperature, whatever dissolved oxygen will be dissolving in water now. So now if I am increasing the temperature is increases, then oxygen will go out. If temperature increases, then oxygen will liberate out. If oxygen only is not there, means then how can these animals will be living in the sea or that in a water zone or that in water? Okay, so that's why, so these aquatic animals, those are very comfort in cold water. They will live in cold water, not in hot water. If I am going to heat, then dissolved oxygen will come out, and so this make harm to the aquatic animals. So these are two main important factors on which the solubility is going to depend upon. Then we are going to talk about third factor, but that is not in this video. So we will take up that in different video. So that is effect of pressure. So until then, thank you.